Oh, hello, this is Miraj Patel, and today we're going to start Unit 2, and Unit 2 is all about atomic theory. And so today we're going to be specifically talking about is the atomic theory and structure. Then we're going to be talking about um, three types of radiation, and last but not least, we're going to be talking about the how to calculate atomic mass and atomic numbers, number of protons, number of neutrons, and number of electrons for each element. And so before we start to talk about atomic theory, here are some three jokes. And so Mr. Proton says, I live in the nucleus. Mr. Electron asks, are you sure? And Mr. Proton replies, yes, I'm positive. Get it? Because protons are positive. And second joke, or second line says, Mr. Neutron was asked if he supported more gun control or the right to bear arms. He replied, I don't know. On most issues, I'm neutral because neutrons are neutral. And the last riddle is, what do you do with dead elements? Anyone can guess? Well, you bury them because it's like bury them. Oh, I know, these jokes are pretty cheesy. But now we get to the real stuff. And so here's atomic theory. And so the first person to propose about or even think about atoms is Democritus, and he proposed that atoms were tiny indivisible objects. And an atom is the smallest particle of any matter that retains its identity. So an atom is the smallest part that has the same properties as the larger part. So like if you think about an element like gold, ingot of gold and an atom of gold will have the same exact properties. But if you break an atom even further, you'll just get to protons, neutrons, electrons, and they don't have any properties like actual gold. And in 1803, Dalton had developed a theory about atoms, and it has four conclusions. And so the first conclusion is all matter is composed of tiny indivisible atoms. And then the second conclusion is in size, mass and properties of atom of the same element are identical. And atoms of different elements are different, have different properties, mass, size. And the third conclusion is atoms can chemically combine, separate, or rearrange. And fourth, atoms combine in simple whole number ratios to form compounds. So pretty much atoms can combine in whole numbers, but they can't combine in like decimals. So if you have H2O, you can't have H and half of an oxygen. So it has to be whole number ratios. And obviously atoms can combine chemically, and that's how we get reactions and decomposition and synthesis and all sorts of reactions. And in 1904, J.J. Thomson did a cathode ray experiment. And so here you have two wires, and the wires have electricity flowing through it. And there's a magnet on the side of the cathode ray. And so on the next slide here, so there's a magnet or positive plate and negative plate. And so as the electrons flow through the voltage or element, so these electrons move towards the positive plate. And so he discovered that there's a negatively charged particles, because as we know that negative particles like to attract to the positive plate, or like how magnets work. And so he reached the conclusion that atoms have negatively charged particles called electrons, and he developed the plum pudding model. And he said that atoms have a positively charged material, and then there's these electrons just floating around like plum in a pudding, and so they're just spaced out equally. And then Ernest Rutherford did a gold foil experiment, and then he discovered the nucleus based off of his laser, and pretty much he was shooting tiny alpha particles, which are just protons and neutrons, and he was expecting the result that they'll just go straight through like this. But that wasn't the case, and it actually dispersed like this. And he pretty much hypothesized that there was something in the center that, or something in the atom that was deflecting it. But some of the light went through, so there's still some space in, but there's something in the middle of the atoms, and so that's pretty much what he discovered, and it became called the nucleus. And a nucleus is a tiny, dense, central positive core of atoms containing protons and neutrons. And so he reached the conclusion that atoms are mostly empty space filled with electrons, and the positive charge and mass are in a tiny central region, which is called the nucleus. And this is what, in fact, deflected the light. That's why atoms block light or alpha particles when you do this type of experiment. And here, this picture is supposed to show how much space, relative space, there is in an atom. And so if this blue dot was the nucleus of an atom, then the electrons will be all the way outside at the edge of the stadium. So that is a ton of space in the atom. So remember that atoms are mostly empty space, and the space is taken up by the orbitals of the electrons. And there's 3 subatomic particles. I'm sure you've heard of them before. Protons, which are positive, so, and their symbol is P+, just 1+, that's their charge, and they weigh a mass of 1. And then neutrons are neutral, and neutrons are, the symbol is N to 0, and they have no charge, and their mass is also 1. Electrons are E negative, that's their symbol, and they have a -1 charge, and their mass is practically 0 because it's so small that scientists just assume it's 0 because they don't really have much significance. And again, these are the 3 models. So Dalton, he didn't really propose much about the electrons or protons or anything. He just had 4 conclusions about their properties or atoms. J.J. Thomson proposed the plum pudding model, where the electrons are just spaced evenly throughout the atoms. And the last one is Ernest Rutherford, and he discovered the nucleus based off of the gold foil experiment, and discovered that the nucleus is the thing that's blocking the light from traveling through. And here is a quick quiz on what we learned. And so the ancient Greek philosopher Democritus is credited with suggesting that atoms react in whole number ratios. B. Atoms can change into other elements. C. All matter is made up of indivisible atoms. Or D. Atoms are stupid anyway. Well, right away you can eliminate D because the answer is so broad and like so ridiculous. And if you recall, Democritus didn't really go much into detail. He just proposed that atoms are just made up of small indivisible atoms. So the answer must be C, because he didn't remember, he was all the way back in the day when they didn't have scientists or any technology to discover anything. Okay, so question 2. Dalton's atomic theory improved earlier ideas about atoms by A. Teaching that all matter is composed of tiny particles called atoms. B. Theorizing that all atoms of the same element are identical. C. Using experimental methods to establish a scientific theory. D. Not relating atoms to chemical changes. And so, go back to the question. Dalton's atomic theory improved earlier ideas by. So, how did he improve it? So, if you recall from the last unit, to perform science, you have to perform experiments and observations. And so the only answer that explains how he did it was C, because he used experimental methods. So he used a scientific method, and used observations to establish a scientific theory. These two tell what he actually accomplished by his theories, and this one, it just doesn't even make sense at all. And which of the following is not part of Dalton's atomic theory? So all elements are made of atoms. B, all atoms of the same element are identical. C, different elements can mix or combine in simple whole number ratios called compounds. Or D, atoms can change into other atoms through chemical reactions. Well, if you remember Dalton's atomic theory, we'll just go quickly back to it. He pretty much said that, matter is made up of atoms, and he talked about how atoms can react. And so here are the first two. All matter is composed of tiny indivisible atoms. 2, in size and mass and properties of atoms of the same element are identical, and atoms of different elements are different. Atoms can chemically combine, separate, or rearrange, and atoms combine in simple whole number ratios to form compounds. So going back to the question. So he did say all elements are made of atoms, so you can eliminate that one. And he did say atoms of the same element are identical, because he talked about how atoms of the same element have similar properties, and atoms of different elements are totally different. And he said that atoms can combine in simple whole number ratios called compounds, but he did not mention that D, atoms can be changed into other atoms through chemical reactions. He said that they can combine and separate and rearrange, but he never said that the atoms themselves will change. So that's a key word that messes up this answer. And which of the following is true about subatomic particles? Protons and neutrons are positively charged. Electrons have practically no mass. Protons and electrons are in the nucleus. Or D, neutrons and electrons have no charge. Well, let's quickly go back to the slide about the subatomic particles. So here are the three subatomic particles. Electrons practically weigh nothing at all and have negative charge. Protons are positive 1 charge and they weigh 1. And neutrons are neutral, so they have no charge and weigh 1. So let's go back to the question. So which is true? So protons and neutrons are positively charged. If you recall, neutrons are neutral, so they're not positively charged. So you can eliminate A. Let's skip B for now. C, protons and electrons are in the nucleus. If you recall the stadium diagram, if the nucleus was as big as that little blue dot, then the electrons would be outside of the stadium. So electrons are definitely not in the nucleus. So you can eliminate C. And D, neutrons and electrons have no charge. Well, electrons are negative, so that just eliminates D. So B is true. Electrons have practically no mass, and that's why we don't use that to calculate mass, because it's so small that it just practically weighs nothing. And the last question, most of the volume of the atom is occupied by electrons, protons, neutrons, or protons and neutrons. If you remember the stadium, the blue dot was the nucleus, which is where the protons and neutrons are, and the edge of the stadium is where the electrons were, and the nucleus barely takes up any spot, and so electrons are the ones that take up all the space. So the answer is A, electrons, because the electrons orbit around the nucleus, and they're pretty much the things that take up the most space in an atom. And so the next slide is about the types of radiation, and there's 3 types. And before we talk about the types, radioactivity is spontaneous emission of high energy radiation or charged particles from a nucleus of an atom. And The reason it's caused, or why atoms normally don't like radioactively break down, is because there's a nuclear force that holds the neutrons and protons together. And if the repulsive force, or the force trying to break them apart, is stronger, then the atom will radioactively break apart. And there's three types of radiation, like I said. Alpha particles, which are two protons and two neutrons. Beta particles, which are just electrons. And gamma particles are just waves of light. Or if you remember that the electromagnetic spectrum, gamma rays have the most frequency and they have the most energy, so these waves are so deadly and they can cause cancer. And so the alpha particles are the weakest, beta particles are the second strongest, and gamma particles are the strongest. So there's three types of radiation. So alpha, because it's so weak, it can be stopped by paper, but beta and gamma will still go through, and beta will be stopped by aluminum, and gamma is the strongest, so it needs lead or 3 feet of lead or concrete to stop it. And here is some more information. And so alpha particles are pretty much helium nuclei, because they have two protons, two neutrons, just like helium does. And their charge is 2 because the protons each have one positive, so there's 2 protons, and the neutrons don't have any charge, so it's only +2. And mass, they weigh 4, and they're stopped by paper. Beta particles are just one electron, and they have a charge of -1 because it's just an electron, and they weigh nothing, and they're stopped by aluminum. And gamma rays are just energy, so have no charge nor mass, and they're stopped by 3 feet of lead or concrete. And here's a quick quiz. Certain elements are radioactive because their atoms have A. more neutrons than electrons, B. an unstable nucleus, C. a small nucleus, or D. more neutrons than protons. Well, if you remember, there's a force called the nuclear force in an atom, a nucleus, and it holds the protons and neutrons together and keeps it there. And so, if atoms are radioactive, that means the repulsive force is greater than in the nucleus. So pretty much the force is unstable because it just wants to go. So the answer is B. And which property does not describe an alpha particle? A, 2+ charge, B, a relatively large mass, C, a negative charge, or D, a low penetrating power. And if you remember, alpha particles are the weakest type of radiation, and they do have a +2 charge because they have 2 protons, 2 neutrons, 2 protons. Each proton has a charge of 1, so 2 has 2, and neutrons don't have any charge, so they don't contribute at all. And then they do have a large mass because they weigh 4 units, while all the other two types of radiation weigh nothing. And D, they do have a low penetrating power because they can be easily stopped by just paper. And so that is pretty weak. And so C is false because they have a +2 charge. So if you wanted to do this shorter, if you knew A, that means it's not negative charge. So you could have, if you knew A is true, you could have just jumped to C and knew that was false. Just FYI, if you want to do a shortcut. And 3, when a radioactive nucleus releases a high-speed electron, the process can be described as oxidation, B, alpha emission, C, beta emission, or D, gamma radiation. Well, an electron released from an atom is called beta particle, so this must be beta emission. And don't worry about oxidation because we haven't talked about this. So that'll be in a few units ahead. And the last question is, which of the following symbols is a beta particle? So let's go back to the chart about beta particles. So beta particles are B negative, or they're 0 e to the subscript -1. So let's go back to the question. So which is a symbol of beta particle, and once you see this one, you know that's the answer. And just to be confused, just to clear the confusion, that C would be incorrect because there's a plus sign, so because this negative sign is the correct charge of an electron. And now the last PowerPoint I have today is about atomic numbers and finding mass numbers and how to calculate it, which is pretty easy. It's just addition and subtraction. And so on the periodic table, there's tons of numbers. And so today we're going to talk about what these numbers are. So there's two types of numbers. There's atomic number, which is the number of protons, and there's mass number, which is the number of protons plus neutrons. And because these weigh 1, this gives you the mass, and we don't really count the electrons because electrons just weigh nothing. And atomic number also tells you the number of electrons. And so today we're going to just calculate some. So here's a chart, and it has the element, atomic number, protons, neutrons, and electrons. And so if we know the atomic number, we can go to the periodic table and find this element. So if you are looking at your periodic table, you look at number 19 and you find that it is potassium. And first we're gonna just fill out that it's potassium, so we just write the symbol here, K, and then we can figure out the number of protons because the atomic number is the number of protons, and from that we can figure out the number of electrons because there's an equal number of protons and electrons, so the charges cancel out. So atomic number is giving you the protons and electrons. So electrons is also 19. And do you remember how to calculate the atomic mass? Well, the atomic mass is the sum of the protons and neutrons. So in this case, it will be 39. And so for this next element, which is S for sulfur, it is number 16. So we found the atomic number 16. An atomic number tells you the number of protons, which is also 16. And it also tells you the number of electrons here. And because the protons and electrons always cancel out, so otherwise we would have positive atoms or negative atoms, and we don't want that. And to find the atomic mass, we add protons and neutrons, so 16 plus 17 is 33, and 33 right here, and the atomic number goes here on the bottom of this little notation. And so the next element we have Ca, which is calcium, and the atomic number is 20, so just from looking at the periodic table. And the atomic number tells us what? It tells us the number of protons and essentially the number of electrons, because protons and electrons are always the same. And we can go ahead and calculate the number of neutrons by subtracting 20 from 39 to get 19. And electrons, as I said before, are the same as the number of protons. And so try doing this one on your own. And so if you want, you can pause the video and just do it and then check your answers. And so if we have the number of electrons we have the number of protons and the atomic number. And so the number of protons is 6 also because they cancel out. And the atomic number is 6 also. And so from the atomic number, we can tell what element it is by looking on the periodic table at element number 6, which is carbon. And because we know the atomic number, it just goes right here underneath the notation. And the number of neutrons is you can get it from subtracting 6 from 14, and you get 8, and that is the final answer for the last problem. And the next thing we're going to be talking about is isotopes. And isotopes are just elements with a different number of neutrons. And so the thing that's the same about isotopes of a same element is that they have the same number of protons, same number of electrons, and they're the same element. They have the same exact properties, but they have different numbers of neutrons, and they have a different name, but they're still the same element. So not to be confused with the element name. It's just the different number they put at the end of the element name. So like, and because they have a different number of neutrons, they have a different mass. So here's some isotopes of neon. So we have neon 20, neon 21, neon 22. Notice how the protons stay the same. Number of protons 10, 10, 10. Number of electrons stays the same, 10, 10, 10. But the number of neutrons can change, and they don't affect the properties at all. You can have like 30 neutrons if you wanted, but if you had 10 protons and 10 electrons, the atom will still be the same. And here's a quick quiz. And the first question is the number of protons in the nucleus is the mass number A, the atomic number B, C, the same as the number of neutrons, or D, the total of protons and neutrons. Well, the number of protons, so we're just talking about protons. If you remember, atomic number is the same thing as the protons. So in the nucleus is the atomic number, because while we were calculating, if you remember by now after doing a few problems, that the atomic number tells you the number of protons and also tells you the number of electrons. And the mass number is the number of protons, B, the number of neutrons, C, the total number of protons and electrons, or D, the total number of protons and neutrons. Well, the mass number, if you recall, is gotten by adding the number of protons and neutrons, because the protons and neutrons both weigh 1 and the electrons don't really weigh anything at all. So the mass number is calculated by adding the number of protons and neutrons. Isotopes of an element have the same mass number, B, different atomic numbers, C, the same number of protons but different mass numbers, or D, the same number of protons but different number of neutrons. Well, let's just start eliminating answers. So A, the same mass number. This is false because isotopes have different number of neutrons, and the neutrons are used to calculate in the mass, so they do change the mass. So you can eliminate A. B, different atomic numbers. Well, isotopes still have the same number of protons and neutrons, so all they do is have different number of neutrons, which do change the mass, but the atomic number still stays the same. C, the same number of protons but different mass numbers. This is true, but let's just check D. So the same number of protons but different numbers of neutrons. This is also true, so if you got C or D, you were correct. And how many neutrons are in an atom of potassium 40? So if you go to the periodic table and find potassium, it does, well, they give us the mass here, and the atomic number is 19, they just told us. But if you didn't have this, you would just go to potassium and look at the atomic number. And so how many neutrons are there? So the mass number is calculated by adding the number of protons, so 19, plus the number of neutrons equals 40. So you just subtract 19 from 40, and you would get B, 21 neutrons. And this brings us to the end of the video. And I would like to thank Ms. Harper for providing me the PowerPoints and teaching me this stuff so I can share this with you. I hope this helped you learn something about atomic theory and structure. And if you have any questions, ask your chemistry teachers. And we'll see you during the next video. And we'll be talking about moles, chemical reactions, and how to calculate grams. And we'll see you later.